All right, today we're going to do 1.5 notes, domain, range, and functions, page 11. This is the last section of Unit 1, so know that tomorrow is the review, and then in 2 days you have a test. So we've almost made it through our first unit together. Yay! So today we're going to talk about the naming of a domain and range in a picture and from a list. We're going to determine if a relation is a function, and we're going to find the excluded domain. Lots to do today. So a relation is just a set of points. I'm going to give you two different examples here. So set A, you use the curly brackets, and then it's points 1, 2, 3, 4, and 5, 6, and then end curly brackets. I'm also going to give you set B here, which is curly brackets, 4, 3, 2, 1, and 4, 7. You'll know it's a relation when you're listing it and it's in a little curly bracket here. You have to have those when you're naming a set of points. So a function is when each x value has only one y value. So every x value only has one y value. So in example A, if you look at your x values, they're 1, 3, and 5. Notice each x has only one y, so A is considered a function. But when you look at B, this x value of 4 has a y value of 3. But this x value of 4 has a y value of 7. Since they don't match, function or set B is not a function. Okay, the domain is the x values that make the function work, so you don't get an error. And so if you look at set A, my x values in my domain would be 1, 3, and 5. When you list this, you always go least to greatest without repeating, so that'd be 1, 3, 5, and you put it inside curly brackets and separated with commas. For set B, the x values are 4, 2, and 4. So you go least to greatest without repeating. So the smallest x value is 2, and then 4, and we don't write 4 again. So it's just 2, 4 in curly brackets, least to greatest without repeating. Okay, for your range, this is the y values. These are the output of the function. So if you look at set A, my y values are 2, 4, and 6. Again, you always write at least to greatest without repeating. So that would just be 2, 4, and 6 with a comma in between in curly brackets. For set B, the y values are 3, 1, and 7. So again, least to greatest without repeating. So this would be 1 first, then 3, then 7, separated by commas inside curly brackets. For set notation, this uses inequality symbols for the range of values. This time I'm going to give you 3 examples. So the first one in curly brackets is 1 is less than or equal to x is less than 5. That means x is between 1 and 5. It can equal 1, but it's not equal to 5. Another way this could look is in curly brackets, y is greater than 5. And then finally, we have all real numbers. So it's like a capital R with 2 lines on the R here is typically how you write it. And that has to be inside curly brackets. Whenever you're using set notation, use curly brackets. Interval notation uses square brackets when it's equal to a number, and it uses parentheses when it's not equal to a number. So for example, I'm going to translate each of these set notations into interval notation. So like I said, I want x to be between 1 and 5 here. It's equal at 1. Since it's equal, it's going to get a square bracket on the number 1. Notice it's not equal at 5, so it's going to get a parentheses on the 5. And we want all numbers between 1 and 5, so you write it like this. Square bracket at 1 because it's equal, parentheses at the 5 because it's not equal to, with a comma in between. This is not creating a new point. It's saying the numbers 1 through 5, including 1, not including 5. Let's take a look at the next one. We have y is greater than 5. Since it's not equal to 5, not equal is a parentheses, and then you always go smallest number first, and then the biggest number last. So if our smallest number is 5, what is greater on the end? It would be infinity. So this is starting at 5, but not equal to 5, and then going on forever to infinity. And since you can't reach the end of infinity, you always use parentheses at the end of infinity. Now we're going to translate all real numbers. So if you think about the smallest number first, that would be negative infinity. And then the biggest number last would be positive infinity. And again, you always use parentheses when you're naming infinity. The vertical line test is any vertical line will only touch one point on the graph to be a function. So if you look at the first example, if you draw on a vertical line, it's only touching the graph at one point. So this is a function. But if you look at the second example, if you draw in a vertical line, notice it's crossing the graph at 1, 2, 3, 4 places here. So therefore, this picture is considered not a function. All right, so number 1 says to identify the domain and range and then determine if the relation is a function. So if I look at here, my domain is my x values, and it's always x comma y, so it's the first number in the parentheses. So my x's are 3, 5, 6, 5. Again, least to greatest without repeating. So that would go 3, 5, don't repeat the 5, 6. So 3, 5, 6, separated with parentheses with the curly brackets around it. For your range, it's the y values. So that would be 12, 20, 24, and 19. You have to do it least to greatest without repeating. So that would be 12, 19, 20, 24. Separated with commas with the curly brackets around it. Is it a function? So does each x value have only one y value? In this case, the answer is no. Here, 5 is going to 20, but over here, 5 is going to 19. It can't go to two different y values, so this is not a function. All right, you're up. Go ahead. What is the domain of this function? Okay, so you should say 7, 9, 12, and 13. That's least to greatest without repeating. Commas in between with curly brackets around. What is the range? Okay, hopefully you just said the number 6 because that is least to greatest without repeating. Curly brackets around the 6. Is this a function? Yes, it is a function. Since each x value has only one y value, it is a function. So it's okay for the y to repeat. It's not okay for the x to repeat. All right, number 2 says to identify the domain and range and then determine if the relation is a function. So notice these are no longer sets of points, but it's going to be a whole bunch of points on this line since we have arrows here. So your domain values are your x's. Remember the x's run left to right. So what's the smallest x value on this line? Well, since the line keeps going left, 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 the smallest x value would be negative infinity. And then going to the right, the highest to the right x value would be positive infinity because it keeps going to the right. So our domain is negative infinity, comma infinity inside parentheses. Or if you wanted to use set notation, you could use all real numbers with curly brackets. For your range goes from the y values, and then you start at the bottom and move your way on up. So the lowest y value on the line, since it keeps going down, would be negative infinity. And then the highest y value since the line keeps going up, would be positive infinity. Or you could write it as all real numbers in curly brackets. To determine if the picture is a function, you do the vertical line test. Notice that passes the vertical line test at all points, so yes, it is a function. All right, you're up. What is the domain? Is it negative infinity to infinity or all real numbers? Or is the domain -3 or x equals -3? Domain is your x's, so starting left, working your way to the right, your smallest x value is negative infinity to positive infinity. So we're all real numbers. That should be your answer. What is the range? All right, remember range is your y value. So you start on the bottom, work your way up to the top. Notice the only y value this graph has is -3. So you can either write it as in square brackets -3 or y equals -3 in curly brackets. Is this graph a function? Yes or no? The answer is yes. It passes the vertical line test, so this is a function. All right, number 3, identify the domain and range and then determine if the relation is a function. So this is no longer a line, it's a set of points. So to name the domain, you start on the left. The smallest x value is -5. And we're going to keep going. The next x value is -3. The next x value is -1. And then +1, +2. And that's as far as to the right it goes. So that's all of my x's from these points. Your range is your y value, so you start on the bottom. The smallest y value would be at -2. As I move up, the next y value is 0, and then 1, and then 2. And that's as high as it goes, so we can put a curly bracket on the end of that. Is it a function? This is if we do the vertical line test. Notice if you draw on a vertical line through all of these points, it works until you get to x equals 2. Notice it has 2 points, so this is not a function. Fails the vertical line test. All right, I'm going to skip B because we have like decimals and stuff. We don't need that in our lives. Let's move on to number 3C. So it says find the domain. Notice this is a parabola. This is going to keep opening left, 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 and then right, 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 right. So when you name the domain, as far left as you can go would be negative infinity. And then as far right as it'll go, it'll be positive infinity because it keeps going down and right and left over here. If you don't want to write it this way, you could also write it as all real numbers. For your range, it's your y values. You start on the bottom. So notice it's going down to negative infinity. And then notice the y values go all the way up to 5. So you could write it as negative infinity all the way up to 5. And then it's including 5 because that's a solid dot on the parabola. Or if you don't want to write it this way, you could write it as y is less than or equal to 5 in curly brackets. To see if it's a function, you do the vertical line test. Notice it doesn't cross the graph in more than 1 point, so yes, this is a function. You're up. What is the domain of this graph? All right, remember domain runs from left to right. So the smallest x value is -4. And then the graph keeps going right forever. So this would be -4 and then infinity. Or if you prefer, x is greater than or equal to -4 in curly brackets. What is the range? All right, so notice this graph keeps going down, down, down. So the smallest y value is -infinity. And then notice it keeps going up, up, up. So the highest y value is positive infinity. Or you can write it as all real numbers. All All right, so starting to find the domain, you start on the left side. Notice the smallest x value is -4. So it's going to be equal there. So square bracket, -4. And then you keep going all the way to the right. The highest x value is +4. But notice this is an open circle. That means we are not going to be equal at 4, so we can't include 4. So you would write it as square bracket -4, since that's equal at -4, and then comma all the way to +4, and parentheses since it's not equal. Or you could write it as a set notation. So it's -4 is less than or equal to x is less than 4. So x is between -4 and 4. Equal at -4, not equal at +4. And that's all in curly brackets. For your range, it's your y values. So you start at the bottom, mark your way up. So notice the smallest y value is -4, and it's equal there. And it goes all the way to the top to y equals 3. So it would go from -4 all the way to 3. Or if you want to write it in set notation, this would be -4 is less than or equal to y is less than 3. Oh, that should say less than or equal to 3. So sorry. All right, function. Does this pass the vertical line test? Yes, it does. It doesn't cross at 2 points, so this is a function. You're up. What is the domain? All right, so your domain runs left to right. The smallest x value is -1, all the way up to +5. Or you can write it as -1 is less than or equal to x is less than or equal to 5. What is the range? All right, for range, you start on the bottom, work your way up. The smallest y value is +1, and then it goes all the way up to a y value of 7. So it goes from 1 to 7, or 1 is less than or equal to y is less than or equal to 7. Notice it's not all real numbers because these are not arrows, these are dots, so they have endings. Is this segment a function? Does it pass the vertical line test? Yes or no? Yes, it passes the vertical line test, so it is a function. Okay. Next concept, we have functions with no excluded domain. This is when all values of x make the function true. It won't have any errors or asymptotes or holes in the graph or anything like that. So the first example, notice this is just x minus 5. This is just a line. I could plug in any x value I want to here, and it won't give me an error. I could put a fraction, a decimal, a square root. It's not going to give me an error. So for this one, the x's I can plug in would be all real numbers. Notice the same thing is true here. This is x squared, so I know that's going to be a parabola. But I plug in any x value I want, I'll still get a number. So this would be all real numbers that I could plug in. Excluded domain for fractions. When you have a fraction, remember that there is a rule. You cannot divide by 0. So whenever you see a fraction, you have to remember that you can't divide by 0. So to find the excluded domain, you would set the denominator to not equal 0, so you can avoid that error. All right, so for this we have a fraction. I know I can't divide by 0, so that means the bottom, the denominator, I'm going to set it to not equal 0. It really doesn't matter what's on the top. It could be 1, it could be an x, it could be a 55 million. It doesn't really matter. All I care about is I can't divide by 0. So if I solve for x, it's already by itself. So I can say x could be anything it wants to be except for 0. And the way to write that is all real numbers except x cannot equal 0. And that's inside curly brackets. All right, the next one is excluded domain for square roots. If you recall, square roots also have a rule. I can square root 0, but I can't square root a negative. If you square root a negative, it means you're going to get an imaginary number. So since you can't square root negative numbers, that means you have to set the inside to be greater than or equal to 0. So if you look here, this is a square root. It has to be greater than or equal to 0 inside the square root. So if you were to solve for t, t's already by itself inside the square root. So I can say t has to be greater than or equal to 0 inside curly brackets. If it's less than 0, it's imaginary. All right, this last one I consider the both situation. You have the square root and you have the fraction. So what you're going to do is have a situation where you can't have a negative number because you can't square root it, and it can't be 0 because you can't divide by 0. So what you'll do is set the denominator to be greater than 0. So in this example, again, I don't care what's on the top. All I care about in a fraction is the bottom. And notice on the bottom, I have a square root. So it's both a fraction and a square root. So you set the denominator to be greater than 0. So you get x by itself. We get x is greater than 0 in curly brackets. All right, let's do a bunch of examples. So here we go. Notice in this example, I have a fraction. The rule for fractions is to set the denominator to not equal 0. Now we have to get x by itself. So we have minus the 2. The opposite would be to add the 2. So I know x cannot equal 2. If it does, I'm dividing by 0. So the domain could be any real number except for x cannot equal 2 inside curly brackets. For b, it's not a fraction. This time I have a square root. The rule for square roots is to set the inside to be greater than or equal to 0. Then we set the inside solving for x. So I have to minus the 1 over. So I have x is greater than or equal to -1. For c, it's a fraction. Notice the fraction on the top, I don't care about that 9. I'm only going to look at the bottom. So I want to say that the bottom cannot equal 0. In this case, it's a quadratic. So I'm going to try to factor this. Instead of using the quadratic formula, let's try to factor. So I'm going to t-chart. These two numbers have to multiply up to x squared, so that'll be x and x. These have to multiply up to 2, so that would be 1 and 2. These have to cross multiply to get the middle term 3x. So notice 2 times x is 2x, plus 1 times x is x. So 2x plus 1x does give me 3x. It checks. Now that you have a factor, you can set the top factor equal to 0 and the bottom factor to equal to 0. So I'm going to minus the 2 and get -2, minus the 1 and get -1. So for your denominator, it can be all real numbers except for these two numbers. So that would be how you write it. All right, for D, I have a fraction and a square root. So this is a both situation. The rule for both is to set the bottom part of the fraction inside the square root to be greater than 0. Again, ignore the top, only focus on the bottom of fractions. So I have to get x by itself, so I would add the 8. So x has to be greater than 8. For E, it's a square root only, so the rule is to set the inside to be greater than or equal to 0. So I have to add the 3 over, and then I have to divide both sides by 2. So x is greater than or equal to 3 over 2. All right, for F, I see no fraction. I don't see a square root, so it's definitely not both. When it's neither of those, this is all real numbers. This is a none situation. It doesn't have a fraction, doesn't have a square root, so you could plug in any number you want. So it's all real numbers. And that's it.